So let's talk about the Cosmos DB today. Uh, so within the Cosmos DB, we have Azure Synapse HTAP concept. So for that, we need to understand what is Cosmos DB. Okay. So for exam point of view, HTAP is more important, the concept and all. So we'll talk about that. And before that, we'll try to see what is Cosmos DB. So we'll try to do the both the things today if time permits. Otherwise, we'll finish the Cosmos DB, then HTAP and other stuff we can discuss in the next session. Okay. So what is Cosmos DB, right? So if you know, like in the traditional database system, okay, all the data will be in fixed schema format, right? Two-dimensional format, and the schema is always fixed, right? So when you design the system for one of the for any storage, okay, for any two-dimensional data, simply you'll go ahead and design the data in the two-dimensional format, right? But sometimes so when the data is coming with a different schema, okay, so what you need to do, you may not be able to do the same thing, okay, with the same database or same table structure. What you need to do, again you need to adjust that schema, otherwise you'll go for a creating a new table, right? So this is kind of a, it's always supports only fixed schema, and if the data is scattered across different properties, okay, not only the schema says about different properties, it may not be able to accommodate, right? So for such kind of thing, we have a Cosmos DB, and it's we have Azure Cosmos DB. So it's Microsoft globally distributed multi-model database service in the sense. So globally distributed in the sense, it's kind of a, I can say, cloud feature. So in every region it's available, and multi-model databases. Okay, instead of the two-dimensional model, we have multi-model. So it can cater to saving multiple properties of a data, right? So that is at high level Cosmos DB. Okay. So what are the features then of the Cosmos DB? So you can say like some of the features, scalability, right? If you know, like it generally the same scalability feature that we talk about the cloud. So it elastically scale throughout the throughput and storage, and take advantage of fast single digit millisecond data access using your favorite APIs. Okay. So Cosmos DBs have different APIs. So based on the data, whatever you choose, so you will choose that API while creating the Cosmos DB. We have like SQL, the traditional SQL API, MongoDB API, Cassandra, Tables API, Gremlin API. So Gremlin is more of a graphical graph database kind of. Okay. So based on the requirement, you will create with a SQL API or MongoDB, Cassandra API. So you generally people like whatever we do, we go with the SQL API. So because of this, so because of the scalability, it can scale throughput, right? Because what happens in the scalability in the sense, so whenever the load is increasing, it can increase its throughput and storage, and when the load is decreasing, so you can adjust it, right? And single digit millisecond data access, so very quickly you can access the data, so you can manage the storage, and you can also, because of the throughput, you can access the data very fast. And performance, so the one of the important concept of the Cosmos DB is it implements local caching of data and automatically indexes incoming data. So in this sense, so what happens whenever the data is there, it caches locally, and as the data is coming in, it indexes automatically, so you don't need to worry about creating the indexes explicitly. Okay. The response time of read write operations are typically in the order of tens of milliseconds. So because of this automatic index and local caching, so whenever you write the data or read the data, it takes only tens of milliseconds, in the sense like 30 milliseconds, 50 milliseconds, 100 milliseconds. It takes just milliseconds. And automatic indexing already reduces operation burden from maintain index, as I was saying. So you don't need to worry about the creating index and adjusting the index whenever you are storing the data. So it will take care of itself, right? And availability, as I said, it transparently replicates your data across all the Azure regions associated with Cosmos account. So whenever you create an account, it will be spread across all the regions, replicating in every region. Okay, so there won't be any issue availability whenever there is a downtime at one center. Okay, so scalability, performance, availability, these are some of the features, and performance is one of the distinct feature because of this automatic index and local cache, right? So that is at high level Cosmos DB. So as I was saying, based on your data model, okay, so you can create multiple, you can create account with different APIs. So Cosmos DB can be integrated in distributed application services using one of the various models. So we have these models. We have SQL API. So Cosmos DB SQL API allows data access like relational model. So when you create the account with the SQL API, so like you can access the data, some simple relational model. So you can query the data, like select, and you can insert the data. Okay, only the thing is that the data will be multi-model instead of two-dimensional model, but you can use same like a traditional SQL. Mongo API. Cosmos DB exposes Mongo API in order to facilitate MongoDB users to easily ramp up on the offering. So there is another type of API, MongoDB. Okay, so where the data will be in different format. So for that explicitly we used Mongo API. All right, give me a minute. Let's see what's Mongo API. Let me show you that. So we'll talk about it. So MongoDB, Gremlin. So Gremlin, I was saying it's a more of a graphical graph traversal language. So sometimes the data will be there where the database will be kind of a graph which will have that nodes and connections. Okay. So for such kind of thing, we use the Gremlin API. So for all the graph traverse language, we'll use the Gremlin API. Cassandra API. So Cosmos DB Cassandra API enable interaction with the data stored in Azure Cosmos DB using Cassandra query language. So whenever you have some data which exposes to Cassandra API, so you use the Cassandra API. So these are all the different APIs databases which we choose usually. So based on your data, how you are going to store and how the data would be storing, based on that you will use the different API. But in this example, we'll go for the SQL API. Table API, application that use Azure tables can be migrated seamless to Cosmos DB by using Cosmos DB table API. If you remember, so within the storage, we have Azure tables as well. So for that kind of data, so whenever you want to shift that data into the Cosmos DB, you'll go for the table API. Okay. So in the traditional system, whenever you have that data scattered across the different APIs, so whenever you want to shift or migrate your data to the cloud Cosmos, so you will create the Cosmos DB account based on your existing data or based on your new data which you are going to model it. Okay, these are the few important models. Okay, and when you create a Cosmos DB, when you want to facilitate that Cosmos DB storage, you need to create a account, right? So what is account? It is a resource that acts as organization entity for your database. Same like in the server, in the same like Azure SQL, you create a SQL account, you create same in the same way you will create a Cosmos DB account which acts as an organization entity for your databases. So you'll create account, then you will facilitate or you will create the databases as per your need within the Cosmos DB account. So each Cosmos DB account is associated with one of several data models Azure Cosmos DB supports, and you can create as many accounts as you need. Okay, so several data models. So whenever you're creating a Azure account, you will associate with a specific data model. So you can create an account with SQL API, you can create an account with Gremlin API or Table API, and there you can create like multiple DBs, and you can operate your data. You can create any number of accounts, that is general. And within the Cosmos DB, you should know some of the terms. The terms are like throughput, request unit, exceeding throughput limit. So what is throughput? So if you know that throughput usually in the database world, what is throughput? Throughput is the number of reads and writes that your database can perform in single unit. Even in the database, you'll talk about throughput, right? So what is throughput? So how many read and write operations a database can done, okay, in a single second. Okay, so within a single second, how many transactions, how many reads is doing, the database is doing, and how many writes is doing. That is the throughput. Now this throughput you will measure with the help of a request unit. Okay, so Azure Cosmos DB measures the throughput using something called request unit. Request unit is which is measured per second. So the unit of measure is request unit is called request per second. Okay, so request unit per second. So when you say when you're measuring the throughput in the Cosmos DB, you will measure saying that request unit per second, because what is request unit? It can be a throughput. Throughput in this is how many reads and writes or operation are performing within the Cosmos DB. So that you will measure with the help of request unit per second. Okay, so you should know this. You should know this all these terms. Okay, when it comes to IDF, we have data integration units, right? And when it comes to dedicated SQL pool, we have DW units, right? And when it comes to here, it known as request unit. So all this terminology, basic terminology and abbreviations, you should remember that. Okay, so request unit is the term which is used to measure the throughputs within the Cosmos DB. Now one more term, exceeding throughput limit. So as its name itself specifies, if you don't reserve enough request units and you attempt to read and write more data than your provision throughput allows, your request will be rate limited. Okay, so your provision throughput allows exceeding limit, your request will be rate limited in the sense. So whenever you are, say suppose you are assigning some 500 request unit and you're crossing that, so that is called exceeding throughput limits. So the important that you should remember is request to unit, which you should remember, right? Now within the Cosmos DB, we have a hierarchy. Okay, so within the hierarchy, what do you have? Right. So why first one is database account, because at high level, what you will create? You create the Cosmos DB database account, and within the database account, like in the database server, we will create multiple databases, right? So here also you'll create multiple databases, right? And within the databases, you have a containers, okay, which holds the actual all the data items, okay, and within the containers, like we have items, procedures, functions, where you will write all the things. Okay, so we have database accounts, and under the database accounts you have databases and containers, and under the containers you have items where you store the actual data, right? So depending on the Cosmos API, container is called with the different terminology. We'll see that. Okay, so container is the collection of different items within the database, and items also we have different names based on the API what you choose. Okay, so database at high level and container is the second level, where you will have all the kind of a model, and within that container we have item. Okay, so say suppose within the database all the containers is called a kind of a tables, right? Say suppose you have a product one, so within the product you have like a cloth table or some other table based on your requirement, right? So say suppose you have HR and payrolls, you have employee table, department table. Okay, so employee department table, I can say that it's a container. Okay, and within that you have actual data, that is the item. Okay. So under the API, SQL API, so it's called database is called database, and container is a container, and item is called document. Okay, so whenever you are adding multiple rows, like in the traditional database, so all those rows are called a document. So when you insert a record, all those records are called document, right? In the Cassandra API, you have key space, the database is called key space, and the container is called table row. So table and row, like same in the traditional two-dimensional model, we have table and row. So, but the database is called not a database, it's called a key space. And then MongoDB, we have like same database. Container is a collection, and item again the same thing as document. And the Gremlin API, we have database, and container is called graph and node and edge. because node and edge, it was saying, right? In the Gremlin supports a graph database. So whenever you have graph database which deals with all the nodes and edges and the connections, entities, then you will go for the graph database. That is a Gremlin API you will use. So there the container is called graph and item is called node or edge. And table API. In the table API, database is there is no database concept, but we have directly container and items which stored in the container, right? That is at a high level of different terminology we use for the various things within the Cosmos. Okay. And what is Cosmos DB? So when it comes to Cosmos DB, with the SQL API, will deal with more. So Cosmos DB, it's like a namespace which used to manage the containers. So as I was saying, so within the say, suppose within the uh, like in core SQL API or MongoDB, it's called a database. So what it does, it manages all the contents, like your DB manages all the tables, like multiple schemas associated with that. So same way, Cosmos DB, it's like a namespace which manages all the containers. So what is a container then? So I just maybe container is unit of scalability for both provisioned throughput and storage without reinforcing the schema. So containers, what is a container? So container is the one, it's kind of a table, I can say in the general terminology, but here unit of scalability for both provisioned throughput and storage without enforcing schema. So when you say when you create a container, okay, so that is a basic unit of scalability. Okay, so when you create a container, there you will mention all this, like how much storage or what is the throughput it has to do within the container. So instead of the DB level, you will do all this operation at the container level. So that is the reason container is a unit of scalability instead of the DB within the Cosmos DB. Okay, and items. What is items? It's repeated. Sorry. Okay. So what is items? We have contain Cosmos DB, then the container, then the item. So item is, I think it got repeated. Sorry, I made some mistake while preparing this. So item is the actual data which you are going to store. So this I'm just trying to explain the database account, the database and container and item. Okay, this is the hierarchy. Now let us create a Cosmos DB account and let's see how it goes. So let me share my screen.
Purushottam, item is more like a schema, right? Where we'll be placing is the target for creating object.
Item, no, item is the actual data.
Actual data.
Yeah. So we'll try to create and you get an idea. So Azure Cosmos DB creating. Right. So when you have this, so all the options, whether you want to do Core SQL, MongoDB, Cassandra, Gremlin, Azure. So for the class, we'll go with only the default one or the regular which you use usually. So this is the Cosmos DB account where you will do. So here I have like free trial, resource group. I have one resource group. Here I'll say okay. Right, and location, let it be default, I will choose. And capacity mode, so provision throughput. So whether you want to provision the throughput or you want to do serverless. Okay, so I'll give you the provision throughput. With Azure Cosmos DB free tier, you will get first 1000 RUs that request units and 25 JavaScript free account. You can enable free tier up to one account per subscription. It's saying whether you want to go for the free tier or like pay as you go. So I'll go for a free tier. I don't want it to cost it anything. So let it be. And here geo redundancy, same thing for your replication. You want to redundant geo redundancy. So it's a now I'll go for this disable because this is just some sample I'm doing, and multi-region writes. So within the zero latency, if you want to do multi-region writes, I'm disabling that as well. So okay, allows us to take advantage of provision throughput file database and contains across the globe. Same thing. So I'll go for this. I'll try to allow from all the networks. Yeah. Now here you can choose the backup policy. So what is the for how many what interval you want to take the backup, and for how many days you want to retain that backup. And copies of data retained, it will be by default, it will be 2, and backup storage redundancy geo redundant. So even the backups also you can do GRS or LRS. So I'll go for LRS for now. Now encryption. Okay. So as I was saying, so we have two kinds of encryptions. So whether when once it is service managed key, so Microsoft provides its own managed key through which all the data will be encrypted. Otherwise, you'll go with the customer managed. You can also, like, customer also can create its own key. They can assign their own key with the which the data will be encrypted. So I'll create this. So within the project, within the actual, when you go for real time, what happens? So there will be analysis of the data which is being done. Then the infra team will create all this stuff. Meanwhile, it's taking place. Let me talk about the Lambda architecture. Okay. So while it's happening, we'll talk about something called Lambda architecture. What is Lambda architecture? Okay. So Lambda architecture is a data processing architecture designed to handle massive quantities of data by taking advantage of both batch processing and stream processing methods and minimizing the latency involved in querying big data. Okay. So whenever you're getting the data, like say suppose you have a source and you're getting tons of the data, batch data and streaming data, right? So you will use the Lambda architecture, which helps to minimize the latency. In the sense, it allows you to uh, query the data efficiently with very speed, okay, with much higher speed compared to regular architecture. And so with the help of that, what happens, there won't be any overhead on the data storage. So it's a generic, scalable, and fault tolerant data processing architecture to address batch and speed latency scenarios with big data and map reduce. Okay. So with big data and map reduce, so it handles all this, and there will be speed latency scenarios will be there. So within that, yeah, so this is at high level what is Lambda architecture talks about. So we have batch data, batch layer, speed layer, and serving layer. So batch layer actually contains all the data. So whenever you store the data, so all the data will be stored over here. Okay. And serving layer, what happens, you'll create some kind of a views on top of batch data, so which will be reside in the service layer. So whenever you want to get the data, simply you'll go with the serving layer and get the data. Okay. And apart from that, so instead of just storing the data at batch and querying the data, we have speed layer also, which talks about the real-time view. In the sense, with the real-time view, what happens, so if the data gets pumped here as well, so you will get the query on the fly. Okay, real-time view. So you whenever the data is getting stored over here, you'll pick the data and you will query the data on the fly. So there will not be any latency, like getting the data, storing the data over there, and just top of it again performing the query. So this latency, this overhead, you can avoid it, and you can perform the data, you can perform these queries very quickly. Okay. On the top of it, we have HTAP, which we'll talk about in detail. So but by the time, let's see if it is done. Yeah, this is done. Let me, so we have we'll go to here. So this is where we have the DB, and where we can create the containers and the data. So we have notifications, and data explorer. And the data explorer is the one of the key component where you will navigate to the data and handle all the data. You will query the data, everything you will do within the data explorer. And here you have I did disabled, so it's not showing anything. Otherwise it will show the actual distribution mechanism. So let's go to data explorer. Why it's not showing? Interesting. So let's add the container and see. Surprise, why it's not showing? Hmm. Let me try in another account which I have. Usually, okay, it came now. So this is a data explorer where you will perform all kind of data operations, right? Now here you'll create the databases and all, right? Now database ID, okay, for this container, okay. What is the database ID I will do? So I'll say something called clothing. The regular example I'll use. Okay, share throughput across containers. Okay, so across the containers I can divide all these things. And here database throughput, auto scale or manual. So I'll say auto scale. So based on the data one, it will take care of that throughput. So here max RU request unit I can give. So how many? So based on the database operation which you want to perform. So like you'll have the idea like how much input read and write operation this database will do. So based on that you will give this max RUs. Okay. Now the container ID. Now you gave this database. Say suppose the products. Okay. So within the products, I'll say something called clothing. Clothing is my container. Okay, it's a table. I can say that. So it's like just imagine that this product is a table and within database, and within the database I have a table called clothing. Okay, and automatic index also I can on and off. So let it be on. And here the partition key. So partition key, what happens, like usually in the partition key within when you specify partition key, so the partition key helps to segregate the data within the partition to store the data. Okay, so it's automatically distribute the data across partitions of scalability. Choose a property of your JSON requirement that has wide range of values and evenly distributes request value. Like any regular partition key, it usually used to partition the data across all the levels, and based on the value whatever the, so within your JSON data, so whatever the value, whatever the key which has many values, okay, so that you'll use the partition key. I don't choose for now, so I'll ignore this. And here the important thing is analytical store. Okay, so this is a new feature which is coming over here. What is analytical store? Right, so Azure Synapse link is required for creating analytical store container. Enable Synapse for this Cosmos DB account. So what is analytical store doing? So within the Synapse Analytics, like which we discussed earlier, Synapse Analytics, okay, you can analyze the data, you can perform analytics on top of Cosmos DB container. Okay, on Cosmos DB on top of Cosmos DB container, you can analyze the data. Okay, so whenever you are creating a container, it separately create an analytical store container when you enable this. Okay, so it will create the regular container, also it will create an analytical store container. So whenever you query the data will be queried from the analytical storage container instead of actual container. Okay, so whenever you go on creating the data, whenever you go on inserting the data within the regular container, the data will be mapped immediately as columnar format in the analytical store container. Okay, see how it is structured, how it is developed. So as you creating the data in the row format, the data will be stored in the row format within the actual container, and immediately the data will be stored in the columnar format in the analytical store container. Okay, so when you query the data in the Synapse, okay, so the data will be retrieved from the analytical container, so there won't be any burden or there won't be any disturbance in the transaction of actual container. So you can enable or disable while creating the container. So I'll say enable because I wanted to show the example from this as well. Okay, now I can say enable. Where it has come. Testing. Looks like there is some issue with that. So, but that's how you do that. But let me show you that as products. I think enable. I did enable partition key is just leave it. So here is creating the container over here. And coming back to here, coming back to here. So what happens? The batch ledger has the master data set, okay, which is immutable. So whenever the data comes, it goes on in adding over here, and the serving layer is batch with a fast query. So whenever the serving layer, what happens, whatever the data is there for the batch, okay, on top of it, it will create all the views. So the data will be queried from here. The speed layer compensates for processing time and deals with recent data only. Okay, as the data is coming over here, okay, the new data, always it's the speed layer will have new data. So whenever you want to query the data, latest data will be pulled from the speed layer. So that is the reason what happens. The data, the query efficient will be faster. Okay, so there won't be any burden on the batch data. All the data is pushed into both batch layer and speed layer. So the data, whenever the data is coming over, it will pulled over here into this and this as well. But here the data go on incrementing and storing over here. But here speed layer, always the data will be latest data will pull over here. So on the fly, the query, you can query the data. All queries can be answered by merging results from batch views and real-time views or pinging them individually. So based on your query, based on the requirement, sometimes you'll combine these data sets too. Sometimes you'll just get the data individually from these data. So that's about the Lambda architecture talks about based on which HTAP has been developed. Okay, and here in the Lambda architecture, we have within the Azure, we have like batch layer, master data stored in the Cosmos DB. So we have how many layers? Batch layer, serving layer, speeding layer. Those are the three components from the Lambda architecture. And within the Azure, so what do you have? The batch layer is in the Cosmos DB, and compute layer is the HDI Spark. So batch layer master data stored in the Cosmos DB using HDI Spark. You can pre-compute your aggregations to be stored in your computer batch views. So all the data will be stored in the Cosmos DB, the batch data. So using Spark, you can like you can create some views on top of it and store it somewhere for the serving layer. Okay, so the serving layer is in Cosmos DB. The speed layer uses Spark to read the data from serving layer. Okay, so once the data is serving layer, so what you'll use the PySpark to read the data from the Cosmos DB. So that is at high level. And here, so this is what the internally linked to HTAP. So by the meantime, so let's go here whether it's created or not. Yeah, this has been created. Now this is the products and all you can see over here. Right? Now you'll go here products. It has been created and it has a container. So you can see here, you can create procedure, functions, triggers, and even you can see the settings, whatever the settings you created earlier. And within settings, you can say time to live. So you can always, you can also see the TTL. So TTL is important concept in general. So which talks about for how much time you want to make it live. So after some time, if you specify any value, what happens? So it will be deleted. Okay, after some time, whatever the one you want to give, whatever the time value you will give, after the time value that will be deleted. Okay, geospatial configuration, you can give the geographical configuration or geometric configuration. So this you can ignore. And index policy, I was saying, So whether you can by default you can switch it on or you can switch it off for auto indexing, right? So all the auto index you can give all the values. Now here the items which exactly you want to grid the items. So here I can create items, like I can create more rows over here. So I can say new item. Okay. So I have some values with me. So let me store over there.
So container is the table name and item is the data in the
Yes,
table.
that I can say row and table. That's it. So I will okay. So I have this value, this product item. Okay, in within this product table, sorry, in the product container, we have sorry, within the clothing container, I have this value. So ID, this is a product ID, category clothing, because I'm dealing with the clothing container, and the manufacturer is Kanto Spot, description, price, shipping, and within the shipping, I'm talking about again the weight, and within the dimension again width. See how many levels are there it supports. So these are first level, and within the shipping property, again I have property weights, dimension, and again dimension property I have width, height, this one. And this is the these are the actual values, and these are the some tagging and all kind of values that you can ignore, but this actually has actual value. So now it
So
is,
if you want to insert, we can do only the JSON format. I mean,
yeah, that's how the data will be there. Yes, JSON.
oh, okay.
So that is been created. Once you inserted, now the data has been pulled over here. And I'll add one more row. Oh, sorry. So I'll go for in. So it has one. So I'll create one more. Save it. Okay. Now you can see the items. One item and two item. You can navigate to the items. Right? So that's how I just inserted some data. Now, once I inserted the data, you can create procedures, you can get the data based on your logic. So let's write some queries over here. So which I was showing in the window. So you can get this like different types of data. Say suppose you want to get the data for the products P. So where PID equal to 1. So you want to get the data uh, wherever the ID is 1. Okay, you'll see wherever the data is there 1. So you are getting that particular item over there, right? And say suppose you want to get the individual values. This values ID, product ID, this is at high level, right? Description and all. Say suppose you want to get those individual values. You can get over there. Right? It gives only ID, manufacturer, description of the data. Right? Even you can do that, what do you call? Like order by and all you can do. So based on the price value, you want to give list of all the items. So these are the list of items, 2 items I got, which I can display over here. So even I can do some joining over here. Products P, join P shipping. Okay, so wherever they are equal, they can do. So based on the different queries, you can get all kinds of data, and you can store, even you can write the procedures and all. So honestly, I haven't worked with the procedures and all, but we use it for one of the application. We use the Cosmos DB in my previous company where we use it to store all the data, telemetry data, more of telemetry data, and we use it to capture that in the data factory. Okay, that we use it to do. But this is the basic concepts of Cosmos DB. So you can create the account, you can create the containers and get the data, and you can also query the data. So you should know or use different models and how do you query the data. If you know this, that should be good enough at high level. And here, yeah. So I was saying about Lambda with Azure. So we have like batch layer is in the Cosmos DB and serving layer is also Cosmos DB. And using the Spark, what you can do, you can just compute the data and get the data out of it, right? Let's see here. What is the HTAP now? Azure Synapse link for Azure Cosmos DB. If you remember, so while getting the data, while like creating the container, I did enable, right? I did enable a Synapse link. So Azure Synapse link for Azure Cosmos DB is a cloud native hybrid transactional analytical model capability that enables to run real-time analysis over operational data in the Cosmos DB. So the terminology is called HTAP, hybrid transactional analytical processing, where you will take the help of where you will get the data from the like from the container without affecting the actual storage of the data. Okay, is capability that enables you to run your real-time analyzer over operational data. So whatever the operational data is there, you can get the data without it disturbing its transactional data. So here we have transactional store. Okay, row stored optimized for transaction reads and writes the data. So you ingest the data, operational data. Okay, you share the data. So this is the Azure DB container. So they have transactional store. So the data will be stored in the row wise because it is efficient for reading and writing. But here analytical store, column store optimized for analytical store. The data will be stored in the columnar format. So it will be easy for whenever I pick the data for analytical purpose. Okay, and Azure Synapse is a link cloud native HTTP, that is hybrid transaction analytics processing, which connects to this Azure Cosmos DB to the Azure Synapse Analytics. So with the help of Azure Synapse Analytics a link, okay, I can connect to the container, and whenever I use whenever I query the data from this Synapse, okay, using dedicated SQL pool, serverless SQL pool or Spark pool, the data will be picked from the analytical store instead of the transactional store, so that you can enable it while you creating the container. Okay, so what are the advantages? As I was saying, reduce complexity with no ETL jobs to manage. I don't need to get the transaction data and regularly store the data in the another container on another DB, so the data will be, I don't need to do that directly. I can like query the data here. With the help of all the queries, I can do all aggregations and all, so I don't need to perform exactly ETL operations to do the data at one place and do the things. So I can get the data, I can create some of the views for all aggregations and computations, and I can query the data on the fly. Near real-time insights into your operational data. Yes, real-time insights in the sense, as the data is coming over here, it's immediately syncing over here. So always you'll get the actual real-time, the latest data. So you don't need to wait like ETL is getting the data from transactional data and storing somewhere, then you are picking the data. You don't need to wait. So always you'll get the operation data. No impact in operational workloads. As I'm maintaining the analytical store, there won't be any burden the transaction store to adjust itself. So it is kind of independent entity. So there will be any load. Optimize for large scale analytical workloads. Yes, so whenever you have huge amount of the data, so it is a perfect way to get the data out of Cosmos DB. So there won't be any burden on the transaction data. Analytics for locally available, globally distributed, multi-region rights. So the data is locally available. Okay, the data is getting locally, even though the data is spread across globally, you are getting the data from the analytical store as it is local. Okay, so if you are in Azure Cosmos DB customer and you want to analytics BI and machine learning over your operational data, then this is perfect. So when you're using the Cosmos DB and you want to perform on top of it analytics and all, so the best way is to go for the HTAP, okay, hybrid transactional analytical processing, where you will connect the data and get the data out of it. Okay, so HTTP is one of the concept, one of the topic which you need to understand with respect to exam and as well as the synapse as well. Okay, so how this analytical store works? Do you have some more? Okay, so how the analytical store works? So Azure Cosmos DB analytical store is a column-oriented representation of operational data in Azure Cosmos DB. As I was saying, it is a column-oriented representation. It's not a row orientation. It is a column-oriented version. The analytical store is suitable for fast, cost-effective queries on large operational data sets without copying the data and impacting the performance of your transactional workloads. Yes, as I mentioned in the previous slide, so you don't need to copy the data and you don't need to perform ETL operation. Directly, the data can be queried from the analytical store on the fly. Analytical store automatically picks up high frequency inserts, updates, reads in your transaction workloads in near real time as fully managed capability of Azure Cosmos DB. No change feed or ETL is required, right? So this analytical store, whenever you're querying the data, this analytical store always makes the data in sync. So even like if inserts happens, updates happens, delete happens to the actual data, the data will be synced on the fly so that there won't be any ETL or change feed is required. You can run analytics with low latency in Azure region by connecting to Azure Cosmos DB container to Synapse runtime in that region. So based on the region, you can connect to that particular region and get the data out of analytical store. Right. So that is that's how this Lambda architecture is can be termed within the Cosmos DB. It's a combination of Cosmos DB and Azure Synapse Analytics. All right. And here, sorry, not security. I just misread it. So here I was saying, right? So the data will be stored in the row store. Okay. And whether when it comes to the column analytical store, the data will be immediately stored as a columnar format. So the data will be, you can see same, but if you see here, the data disk logical representation, say one product, 1, 2, 3. Here, all the one column values will be stored at some location, another column values will stored location. So whenever you get the data, immediately it will pick it up from that particular column and get the data out of it. And auto seek happens always between these two. Okay, that's how this happens. So tomorrow I'll create one of the quickly that Azure Synapse Analytics. Okay, within that I will connect to the same container which I've created now and try to query the data from there. Okay, if the time permits, we'll do some more operations. All right, any doubts how that HTAP works?
Sadman, we are having free account. Will it cost more if we launch Cosmos?